All right, time to dive deep into GCSE Geography. And you know what we're tackling today.
Hit me with it.
Tectonic hazards.
Ooh, yeah, those are fun.
They are. I mean, earthquakes, volcanoes, just all that earth-shaking stuff that just, I don't know, makes the ground feel not so solid.
Yeah, and it's fascinating and terrifying all at the same time.
Absolutely.
Yeah.
But before we get to, like, the Hollywood movie level stuff, we've got to go back to the science.
Yeah, gotta lay the foundation.
Exactly.
So it all starts with this idea of plate tectonics. And basically imagine the Earth's surface is kind of like a cracked eggshell.
Oh,
It's not just one solid piece. It's all these massive plates that are constantly moving around, shifting, bumping, grinding. And that's what causes, all the exciting stuff like earthquakes and volcanoes.
so it's like a giant slow-motion demolition derby happening like right under our feet.
Pretty much. And the place where these plates meet those are called plate boundaries.
Okay.
And that's where things get really interesting because that's where most of the action happens.
Got it. So tell me more about these plate boundaries then.
Well, you've got three main types: convergent, divergent, and transform.
Three different types.
Three different flavors of plate boundaries.
Yeah. Okay, so convergent, divergent, and transform.
Exactly.
Break those down for me.
All right, so convergent boundaries, that's where the plates are actually colliding head-on, like a massive head-on collision.
Oh, wow.
Yeah, and you can imagine the pressure.
That's got to be immense.
It's absolutely immense, and it can buckle the Earth's crust, which is how we get massive mountain ranges like the Himalayas.
Oh, wow.
But sometimes one plate actually gets forced down under the other. It sinks into the Earth's mantle.
Oh, so it's not always like a head-on collision.
Exactly.
Sometimes it's like an under-over situation.
Under and over, and that process that can trigger earthquakes and volcanoes because you're basically shoving all this rock down into the Earth where it melts and creates all this pressure.
So that's how we get those, like, classic cone-shaped volcanoes.
Yeah, exactly. That's your classic stratovolcano like Mount Vesuvius. It's built up over time from layers of ash and lava.
So it just built up over years and years and years.
Millennia, even.
Wow, so cool. And those are the ones that have, like, those big explosive eruptions.
Yeah. They're the ones that everybody thinks of when they think of volcanoes.
Right. But I've also heard about, like, different types of volcanoes, like ones that are more spread out, like giant shields.
Yeah, that's right. Those are shield volcanoes, and they're formed at different types of boundaries, like divergent boundaries, where the plates are actually pulling apart.
Yeah.
So instead of colliding, they're moving away from each other, which allows magma to rise up and create these gently sloping volcanoes.
So like the volcanoes in Hawaii.
Exactly. Hawaii is a classic example of shield volcanoes. They erupt more frequently, but with less violence.
All right.
So it's more like a slow oozing of lava rather than a giant explosion.
Still sounds pretty dramatic, though.
Oh, yeah. It can reshape entire landscapes over time.
I bet.
And it's pretty incredible to watch.
It's just mind-blowing to think that all of this drama is happening because of these, massive plates just moving around.
It's pretty wild.
It is.
Yeah.
And we know, like, earthquakes can be super destructive, but how do we even know, like, how powerful one is? Like, how do you even measure something like that?
Well, that's where the Richter scale comes in.
Okay, the Richter scale.
It's a way to measure the magnitude of an earthquake, basically how much energy was released.
Okay.
So like a magnitude 6, that's a serious earthquake. You're going to see damage to buildings.
Yeah.
But if you go up to like a magnitude 9, that's catastrophic, like the 2011 Tushoku earthquake in Japan.
Right, the one that caused that huge tsunami.
Exactly. That one was devastating.
Wow, okay. So understanding these plate boundaries and the Richter scale, it's not just, for, like, geography class.
It's important stuff.
Yeah, it's like it can actually help us prepare for these events, maybe even save lives.
Absolutely.
That's amazing.
By studying plate tectonics, we can identify areas that are at high risk for earthquakes and volcanoes, and then we can develop early warning systems.
Oh, right.
We can build structures that can withstand these forces, things like that.
That makes sense.
So yeah, it's really about understanding the planet we live on and how these forces shape the world around us.
So it's not just something we learn about for exams. It's about understanding, like, the ground we walk on.
Exactly.
So cool.
And, even though the UK isn't exactly earthquake central,
Right.
we do get some minor tremors from time to time.
Yeah, like just little ones.
Little ones, yeah.
Yeah.
So knowing about tectonic hazards, even in a relatively stable place like the UK, can still be super usable.
That's a good point.
You never know.
Yeah, it definitely gives you a whole new perspective on geography, that's for sure. Keep exploring, everyone.